In this video, we're going to be reviewing parent graphs and their transformations. To get started, what you'll need is your comp book with some graph paper, a pencil, and if you don't have your comp book with you, just some sort of paper. It could be lined paper or blank paper, somewhere where you can write. Ideally, it is graph paper. You'll recognize this test that we're working with because it's attempt 1 of the LT transformations test. We'll do one problem together, and then I'll give you a chance to do one problem on your own, and you'll have some practice later on this class to work with these types of problems again. So we have a graph paired with a set of questions that we have to answer about this graph. First of all, we need to locate this HK. If you'll remember, this is called the locator point on our graph. And this is a quadratic function, so we're going to look for the vertex, the highest point in this case, to identify our locator point. And that point is 3, 2. So I can fill that in here. That means that my H is 3 and my K is 2. When I go to write my equation, I know my general form for quadratics is y equals a x minus h squared plus k. I know my h, that's 3. I know my k, that's 2. What I'm looking for is my a. So I'll leave this part blank, and that's the part we're going to work on next. We're going to try to solve for a. A couple different ways you can do this. Some people got really comfortable with their parent functions and were able to dial in the slope by looking at the function. So if we let this be our starting point to find the next value, we go over 1 and down 1, or over 2 and down 4. 1 squared is 1, 2 squared is 4, and since we're going down instead of up, it's opening downwards, we know it would be negative. So we could just use the function to tell us that the vertical stretch is -1. Another way we could do it is to solve. So when we solve, we pick another point on our graph, and we want to pick one that's pretty easily defined. So I'll do this one, 5, -2. And we're going to call this an xy point, right? Every point has an x value and a y value. And with those two values, I would plug into our equation x, y, h, and k, and then solve for a. So let's see what that looks like. Let's slide over here so we have some space. So I'm going to say y, and our y is -2, so I reference our -2 up there, equals a, that's our unknown, remember? That's what we're solving for. X, which is 5. We already know what our h is, -3, oops. Plus 2. This should not be negative, plus 2. Okay. And we can't forget our square. I forgot it down here. Sorry. All right, so 5 minus 3 is 2, and 2 squared is 4. So we have that. We're going to take away 2 from both sides. Try to get a by itself. -4 equals 4a. Divide both sides by 4. So we're just confirming here that a does in fact equal -1. That means when we go back into our equation and we plug this in, we get a equals -1. Domain and range. Domain is referring to the collection of all of the x values in the function. So because this function is getting wider and wider, the quadratic's getting wider and wider, the number of x's continues on into positive infinity and also into negative infinity. It's just getting wider and wider. The range is referring to the collection of all of the y values, and the smallest y value is also negative infinity because the graph is going down forever, because it's continuing to reach down. The upper part of this graph, though, does have a limit, and that limit is 2. The height, the tallest point of the graph, or the greatest y value is 2, so we put a 2 up here. And I'm going to switch this out with a square bracket. So because that 2 is included in the range, we're going to actually put a square bracket here. And now we're finished with this problem. So this was our quadratic. Let's scroll down and take a look at a cubic problem. So this is a cubic. Actually, I'm going to change my mind. We're going to skip this one, and let's all look at this square root function. I think this problem is slightly more challenging. So go ahead and make sure you can see this graph. And we're going to write down the general form of the equation first. Y equals a square root x minus h plus k. X minus h plus k. Make sure this k is outside of the radical sign. That's important. So take a moment, pause this video, find your locator point, think about what you can do to find a. So remember solving for an xy value and then plugging in for all of these different components of your equation. And then solving for a and then checking it with the graph, and we'll check back in 1 minute. So take a minute, pause, solve for a, write your equation, and then we'll check. Okay, before we check our answers, you've had a minute to work on this on your own. I want you to turn to the people at your table and compare what you have on the page, right? Ask them questions if you have any, offer support if you have some support to give, and let's just talk about this problem for another minute and check in with each other. So using the solving or finding x, y, and solving for a method, I got a equals 2. If we go back to our graph, it makes sense because we have up to over 1. Up to over 1. We know the square root of 1 is 1, so we'd have to multiply that output by 2 to get up to over 1. Again, if that feels uncomfortable, the solving method works equally well, and we go to square root of x minus negative 3 minus 3. So we have an x and y in our equation, and we have the horizontal shift and the vertical shift filled in. Remember that you have to put in minus a negative, so it's minus whatever h is. We could simplify this. Because 2 negatives make a positive, I could rewrite this as 3. But if this helps you remember to include this negative h, then please write it this way the first time and simplify afterwards. All right, we are going to go to our next problem, so make sure you have a little more space on your page. And take a second and set up a set of axes so you have a chance to practice graphing these. So pause the video now and set up your axes. Okay, we should be ready to get started on this. We'll do one together and then I'll give you a chance to try the second two. All right, let's start with our quadratic. So a couple different ways we could go about this. Let's say we are really comfortable with our parent functions and we want to look for the h and the k, or the locator points. So that would be 2, 3. And then graph from there. So normally we go over 1, up 1. Oops. Over, let me do this in red. Over 1, up 1, because 1 squared is 1. Over 2, up 4, because 2 squared is 4. And so on and so forth. So that would be what a quadratic would look like, given that locator point and no vertical stretch. But notice we do have a vertical stretch, or more compression, which is 0.5. So my actual graph would be over 1, up 1/2. Over 2, up 2. Over 3, up 4.5. And I would do that in the other direction as well. And get a flatter graph. Remember, to get full points on this part of the test, you want to show me several accurate points plotted on the calculator. Okay, just getting worse. So this is my final graph. I connect these points at the end and maybe erase the red. Another way to graph this is to enter this into the calculator, so the y equals section on your calculator. You're going to enter in this equation and then press second graph to access the table, and the table will give you a set of those values, right? So you can actually plug in, you can actually find x and y values for, maybe you want to do like -1, 0, 1, 2, 3, and then you'll get your corresponding output and plot those. Take a second to try these next two functions on using your calculator and your set of axes. Remember, to get to the absolute value signs, you hit math, and then I believe you scroll over. You scroll over and you look for the symbol. It should be at the top of the list that says ABS. So that stands for absolute value. So pause this video now and try these two functions here. I know you've given these functions a try, and I just want to encourage you now to make sure that you're checking in with your neighbors. So again, turn towards your neighbors, turn towards the people at your group, ask questions if you have it, and offer support if you feel like you can offer support. And let's pause the video again for about a minute and check in with the people around you. Okay, so these are my graphs for the absolute values in blue. We can see that as looks like an upside down V, which makes sense because the -2, or the A is negative, so it should be opening downward. For C, this is in their square root family function, and we find the locator point from these two values, and then graph it like so. Square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. Again, another option would be to enter this function into the calculator, pull up your table. You can maybe even copy your table down onto this assessment like we did up there, and then graph those points. That concludes the review for this learning target. So continue practicing and asking questions about this topic, and we'll talk soon. Bye-bye.